Okay, so this is part 5 of my Tekno EB48 SL build series. So as you can see, I'm working on the shocks. I'm waiting for the air bubbles to get out of the shocks. So while I'm waiting for that to happen, I figured I'd make this video. These are for the front shocks. I'll get to those in a minute. As you can see here, the main chassis is done. Everything is mounted. The front is mounted. The rear is mounted. The center diff is mounted. This all went together pretty straightforward. I mean, there was nothing too out of the ordinary. One thing that I found kind of interesting is that the, I guess you can call it the center gearbox is actually a multiple piece unit. So this back piece here is actually a left and right piece. The lighting's kind of poor. So there's actually two pieces. You can maybe see the line in the middle there separating them. There's a left piece and a right piece. Then likewise for the front, the motor mount, it's aluminum, and that constitutes the right side piece. And then the left side piece is a plastic piece, and so those kind of slot together. And I think the idea there is, you know, for the bearings to mount into this, you just put the bearing onto one side, and then you clamp it down with the other side. And then when you put this all together, you kind of put, you know, these screws down on the top to hold it in place. And then there are these two screws on the side that I think screws the left piece onto the right piece. It kind of slots under. So it's kind of peculiar that they did it that way, especially for the rear where both sides are plastic. It would make more sense, I think, just to make the rear piece one solid unit. And then you just mount the center diff into that, and then then you clamp it all together on the front side with the left piece and the right piece. It would make it easier for assembly, but actually, come to think of it, for disassembly, if you want to take the center diff out, it actually makes sense now, come to think of it, that there are two sides, a left piece and a right piece, because you want to take the top plate off, and then I assume you would take off this left piece here and this left piece here, and this center diff just pops right out. So I think that's why it's actually in multiple pieces, this center gearbox. So that makes sense. It's a little strange putting it together, though, I have to admit. But I guess that's just how you have to do it to make the center diff easily serviceable. Okay, fair enough. Again, so, all this pretty straightforward, nothing too crazy, just a whole bunch of screws, put the front bumper on, blah, blah, blah. Nothing out of the ordinary there. And I think I already went over the wing part. So that's all set. For the shocks, I mean, the front and rear shocks are the same kind of build. So I figured I'd just go over my thoughts so far while they're still fresh in my head. They give you the parts and the instructions you need to do either the bladder type shock build or the emulsion type shock build. I'm going with the bladder shock build. Just because, it keeps the air bubbles out, and I don't really notice too big of a difference between the two, but at least with the emulsion build, you can get air bubbles building up, and over time it can get kind of sloppy or inconsistent, so you have to replace the oil more often. With a bladder type build, you can leave the oil in there forever, especially with these little shock boots, and it won't get dirty. So a few things. The seal assembly is okay. No big problems there. The pistons are part of a molded parts tree, much like all the little washers and things that go into the seal assembly. They're on this little parts tree here. I'm actually quite surprised that the pistons are molded and not machined. I guess that just comes down to cost. It would be nice if they included machined pistons to get even smoother shock action. But, nevertheless, they are what they are. Just make sure that when you cut this out of the parts tree, that you actually cut the flashing off of the side that the piston was attached to the parts tree. Otherwise, it will bind against the inside of the shock body. That goes for any shock that you're assembling that comes with pistons on a molded parts tree. So just watch out for that. It mounts onto the shock shaft with a lock nut. So usually what I do is I just take a rag and I put some pliers around the rag to hold down the shock shaft so I don't scratch it while I'm holding it down. And then I just screw the lock nut on, because this lock nut actually goes on pretty tight. And the piston itself, maybe it's hard to see, but it's also tapered, which is kind of cool. So it's tapered downwards. So on rebound, the taper side of the shock is going into the oil. I think that should make your rebound damping softer than your compression damping. Okay, so that covers the pistons, and I'm just putting them in, bleeding them right now, waiting for that to all finish up. The thing is, when you, depending on which type of assembly you choose, you have to drill different types of holes in the shock cap. So this is the shock cap. If you want to do an emulsion build, then on this hole here, you have to drill a hole to actually bleed out the oil, because the hole itself isn't already present. You have to drill it in there. And then if you're going to do the bladder type shock build, then they give you 2 little indentations on either side of the shock body, and on either one of them you just have to drill a 2mm hole. So this is to allow the air that the bladder is displacing to come in and out of the shock, because as the shock compresses, it pushes the bladder up, and that's going to push air out of the shock cap. And then as the shock rebounds, the bladder expands, and that's going to pull air in. So you just need to drill a hole to allow that displacement to take place. So that's it for the shock cap. For the actual shock collar, this guy right here that you use to adjust your preload on your springs, I was quite surprised that this does not require an O-ring to mount on the inside of the collar. So if you put together like 1/10 scale shocks, or even like for the SC10 4x4, which technically it's a 1/10 scale chassis, but it's as large as a 1/8 scale chassis. Usually for most shocks, the actual collar that screws onto the threaded shock body, there's a little indentation on the inside, and you mount an O-ring in there. And the idea is that that O-ring just provides some friction so that when you screw this collar up or down, it holds in place and it doesn't move around. This particular collar doesn't do that. It's just a molded part, just like, on a parch tree, and you clip it off and you just screw it right on. So it screws on very easily. But I would be a little bit concerned that this might move around a bit if you're not careful. Like if your hand just sort of grazes across the shock collar while you're working on the car, and then you just have to make sure that you remeasure it and check your preload again. So that's something to watch out for. One nice little touch that I thought was really cool is on the actual shock end piece. They include this extra little lip here with a hole. And on the actual spring cup, there's another hole here with another lip. And the idea is that when you mount the spring on and you put the spring cup onto the shock end, you line these holes up and you thread a set screw through the hole. So that's kind of neat. And let's see, it's right, where is it? Here, you can see that right here. Okay. The idea is that this just helps to hold the spring cup in place. So if you have an accident, sometimes the spring cup might try to pop out of the shock shaft or something. So to prevent that from happening, this basically tightens the spring cup down onto the shock end. That's a neat little feature. So I just thought it was kind of cool. So I'm going to wait for these to aerate out, all the air bubbles out, and then I'll get to, finishing them up, mounting them. And then the rear is going to be exactly the same. Okay, no difference there. And then at some point around here, I guess this is where I start mounting the electronics. I'll make another video and talk about what it's like mounting the electronics, whether it's a tight fit or anything like that. So yeah, that's where I am right now. So as far as the shocks go, I'd say they're not bad. Some ups and downs. I'm not too crazy about the molded parts for the pistons. And I'm not too crazy about the lack of an O-ring inside the shock collar for preload adjustment. But otherwise, the shocks are fine. So it's okay. All right, so that's it for now, and thanks for watching.